Hello, we are starting Unit 2 with Lesson 8-1. So the first half of our unit we're calling Unit 2A will all be about factoring. And so two of the factoring lessons actually occurred in Unit 1. So we pushed them into 2 so that they could all be together. So our first lesson for this unit is factoring by the greatest common factor. And then I also added in factor by grouping, you'll see at the end of this lesson. So we're also going to add here factor by grouping. So the learning targets we have are to identify the GCF of the terms of a polynomial and then to factor out that GCF from a polynomial. And grouping also involves GCF, and you'll see that in a little bit. So we start with an application problem. It says Factor Steel Buildings is a company that makes customizable prefabricated metal buildings. Most office buildings have a conference room, large offices, and cubicles. The diagram shows the front face of one of their designs. The distance C represents the space available for large offices, and P represents the space available for the conference room. Question 1. Use the area formula for a rectangle to represent the total area of the material for the front wall as a product of a monomial and a binomial. Okay, so if we use the formula for area of a rectangle, we know that that is length times width. Okay, so now we can see our width is 10. Our length, however, we've got part of it as C and part of it as P. So we're going to call that C plus P. Because they're not like terms, we can't really add them together. So if the length is C plus P and the width is 10, we could write this as 10 times C plus P, and that's length times width, or width times length. So that represents a factored expression because in question 2, they want us to represent the same area from item 1 as the sum of two monomials. So we could do that by using distributive property. So that would be 10C plus 10P. So that's two different forms of the same expression. And so we're going to be working on the factored expression, maybe starting with something like number 2 and working backwards to number 1. And what property can be used to show those two quantities are equal? And I think I just said that. That would be the distributive property. Well, Factor Steel Buildings inputs the distance C into an expression that gives the area of the entire space. So different expression, we have 6C squared plus 12C minus 9. So this time we have a trinomial, and they want us to determine the greatest common factor of the terms in this polynomial. So the greatest common factor, or GCF, of the terms in a polynomial is the greatest monomial that divides into each term with remainder 0. For example, the GCF of the monomials 24, 6x, and 6x squared would be 6. 6 is the biggest number that can divide into those three terms evenly. So if we look at our polynomial, where we have 6c squared plus 12c minus 9, we think about the biggest number that will divide into each of those expressions. And hopefully you can see that it would be 3. Okay. So to factor an expression, we write it as a product of its factors. Okay, so to factor an expression, write it as a product. So there are steps in factoring a monomial or GCF from a polynomial. So the first thing we would want to do is determine the GCF of all the terms in the polynomial. So if we have this trinomial 6x to the third plus 2x squared minus 8x, we can see that not only can we divide each term by 2, but we can actually factor out an x from each term or divide each term by x as well. They all at least have one x. Then we write each term as the product of the GCF and another factor. And finally, we use the distributive property to factor out the expression. So really, we kind of skip over that middle step. It's really unnecessary, and you'll see that as we practice a little bit of factoring that we typically go right to the third expression. All right, so we will practice some of these now. We're going to do the try these A. We're going to factor out the greatest common factor and write the polynomial with the GCF factored out. So our first expression, we have 36y minus 24. So we want to think of the biggest number that can divide into both of those terms. So we would hopefully see that it's 12. There are other numbers that divide into 36 and 24, but we want the greatest. And so 12 is the greatest. Now we look at the variables, and one term has a y, the other doesn't, so we cannot factor out a y. So now we want to write our expression as a product. So we think about, what would we have to distribute back to get to 36y? Well, since 12 times 3y is 36y, we'll put a 3y there, and minus 12 times 2 is 24. So it's like taking that 36y and that minus 24 and dividing them by 12. Okay, we'll do the same thing with part B. This time we have a 4, a 6, and a 10. So I notice a 2 can be factored out. I also notice that each one of them has at least x squared. So the most amount of x's we can factor out is x squared. And that will leave us with, 4 divided by 2 is 2, and x to the third, since x to the fifth divided by x squared, remember you subtract the exponents, and then minus, and then we have 6 divided by 2, which is 3. And then we factored out x squared, so there's just an x left. And finally, 10x squared, it would be plus 5, because 2 times 5 is 10, and we factored out the x squared, or x squared divided by x squared is 1. We have one more of those to do. We have 15t squared plus 10t minus 5. And so if we look at those three terms, we can factor a 5 out of each one of them. Okay, we cannot factor out a t, however, because we only have a t in 2 of the terms out of 3. All right, so that would be 3t squared. Yes, 5 times 3t squared is 15t squared, plus 2t. 5 times 2t is 10t. And we actually now have to divide negative 5 by 5, and that makes negative 1. So you always want to check your answer by doing distributive. So let's do that for this problem. 5 times 3t squared, yep, that's 15t squared. 5 times 2t, that is 10t, and 5 times negative 1 is negative 5. So make sure you don't forget about that negative 1. So the check your understanding problems we're going to actually do in class is some of our examples, and we're going to leave the 8-1 practice kind of out of this assignment. So what I'm going to do now is go into this process called grouping, because it's very similar to GCF. And so what we're going to do now is what we call factor by grouping. So the process we saw of factoring by taking a GCF out of pairs of terms is called factor by grouping. It's the primary process we use for factoring polynomials which have 4 terms. So again, we're going to be looking at polynomials that have 4 terms as being polynomials that we factor by grouping. So here are the steps we can use. Number 1, we want to arrange the terms so that the first 2 have a common factor and the last 2 have a common factor. Most of the time, you don't have to rearrange the terms. They sort of just show up that way. Number 2, we would factor out the GCF for each pair. And if step 2 produces a common binomial factor, we'll factor it out. If it doesn't, we might try to rearrange the terms. And if step 4 doesn't work, then, well, the polynomial can't factor by grouping. So we'll take a look at a few examples just to illustrate this factoring type. So notice that we have 4 terms here. And so with these 4 terms, if I look at them, I don't have a GCF that could be brought out of all 4 terms. I've got a 2, a 1, a 6, and a negative 3. So, and they don't all share variables. So what we can do instead is we can group the first 2 and the second 2 together. And we're going to do a GCF using those pairs of terms. So in the first 2, I can factor out, it looks like I can take out x squared. So if x squared comes out, then 2a minus c stays in. And you can double check with distributive property. Okay. Now I have to do plus, because there's a plus in the middle. I can factor out from 6a minus 3c. It looks like I can factor out a 3. And I'm going to have 2a minus c. Okay. So what we end up with now is a common binomial factor. We can factor it out to the front. So it's 2a minus c. And then the leftover factors, what we would have left after dividing out 2a minus c, would be the x squared plus 3. And that's what we call factor by grouping. And so now we have it written as a product of two binomials. Kind of ran into the space of this one, but we'll give it a try. So same idea. We're going to look at grouping, although this time I noticed there's a minus sign in the middle, so we want to be careful with that. So of the first two terms, I see an a squared that can come out. So I'm going to take out a squared. And when I do that, I'm left with x plus 3y. In the next expression, I see a minus there, so I have to factor out negative, and I can factor out a 3, and that's going to leave me with x. And then be careful, negative times positive would get me back to that negative right there, so we need to make that a positive, and also 3y. So now, again, we have that common factor. So if it's a common factor, we can factor it to the front. So that's x plus 3y. And then our leftover is a squared minus 3. And now it's fully factored. I'm going to try to squeeze in part C just to get one more practice problem in there. And so let's try a little grouping. Again, I see a minus in there, so we'll be careful. So it looks like I can take out a y. And when I do that, I get x minus 5. Factor out minus, this time it's 2, x minus 5. So now I have x minus 5, what's the common factor? And y minus 2, which is our leftover factor, and we're good. So there's one more set of examples on factor by grouping, and so these might be a little more challenging, so we're going to give these a try, take them a little slower maybe. So 4 terms again, so I'm going to go ahead and try to group this way, see what happens. So the first 2 terms look like there is an a in common, so I'm going to go ahead and take out a. And then I have 4a plus 5b. Okay, now I have to factor out a minus. 8 and 10, it looks like I can take out 2. And that leaves me with 5b minus times plus will get me minus, and that's 4a. So when we do that, we see our factors, and our common factors, one of them is 4a plus 5b, the other is 5b plus 4a. Hopefully you recognize that those are the same expressions. And so we do have it factored. Now we can pull out 4a plus 5b, and we can have left a minus 2. So that actually worked out okay. Now part B, we have 2 terms in the that we'll group together, and then a second pair of 2 terms. So I see a 3, and I think that's it for the first expression. So 3 comes out, 2ax plus bd minus the second expression. It looks like I can factor out, I don't see any common factor. So what I might want to do on that one is maybe rearrange the terms a little bit. So let's start over. And let's rewrite this expression now. I know that if I put together 6ax with the minus 2ad, I could factor something out. I see an a and a 2 that could come out. And maybe I can try to group together the positive 3bd with the minus 9bx. So let's see what happens there. If I group those two, I can take out 2a, and then I'm left with 3x minus d. And if I group in the second 2 terms, I have a 3 and a b that can come out. And that's going to leave me with looks like D minus, and then that would be 3x. Okay, so those are not exactly the same this time. And so what we might need to do is think about factoring out a negative instead of a positive. Okay, so if I do that instead, 2a times 3x minus d, if I factor out a negative and then 3b, then I actually have minus d and plus 3x. Now they're the same. 3x minus d and minus d plus 3x are the same. So now we can continue factoring. So we'll pull out 3x minus d to the front and 2a minus 3b, and that's going to be my final answer. And so I forgot to box this one in. We'll do that real quick. And we don't have any room left for C, so I guess we're going to skip that one. But that's all we have for greatest common factor and grouping. Practice problems are going to come on a worksheet on a handout that should be attached to this assignment. So you can check Google Classroom for that.